Hello everyone, my name is Guillaume Cos. I'm working for Phimeca as mechanical and reliability engineer, and I'm responsible for PhimecaSoft. It is a software dedicated to robust design and reliability analysis, and it can be linked with any calculation code like Ansys, Abacus, and other physical models. The purpose of this video is to present the new interface developed to make the coupling easy between PhimecaSoft and Ansys Workbench. This will give you the possibility to make your design more robust. There are two main objectives of such a coupling. The first one is to perform sensitivity and reliability analysis of a current design. The second one is to improve the design performance or robustness by using all the capabilities of PhimecaSoft in uncertainty propagation and reliability analysis. I have developed a demonstration on a simple case study. Let me present you how it works. On the left side, you can see the starting interface of PhimecaSoft, and on the right side, the Ansys Workbench model. The finite element model used for this demonstration is a simply supported beam. We will focus on the input and output parameters in order to prepare the coupling. There are 5 input parameters: the length of the beam, the dimensions of the beam cross-section, the Young modulus of the beam, the applied force at the middle of the beam, and the quantity of interest is the maximal deflection of the beam. The definition of the parameters has to be done manually in Design Modeler and in Mechanical. It is possible to verify that all the inputs and the output are well defined in Ansys Workbench by clicking on Parameter Set. You can see here the 5 input parameters and the outputs. P5 refers to the maximal deflection of the beam. The finite element model is ready, and this workbench can be saved and closed. Now we can start doing the coupling with PhimecaSoft, which you will see how easy it is. The first thing to do is the creation of a new physical model. Right-click on Physical Model, then click on New Physical Model. You can rename your physical model, in our case, Coupling, then click OK. You can now click on the button with the hammer and go down in the list to click on Ansys to start the coupling interface with Ansys Workbench. You only have to look for your finite element model and load it in PhimecaSoft. You can see that the input and outputs are automatically detected by PhimecaSoft. Click Done and click on the main window to finish the coupling operation. By clicking on the first button, Evaluate, it's possible to evaluate the output values from PhimecaSoft and to verify that the coupling is working correctly. PhimecaSoft launches the updating of the Ansys model with these input values. The updating can take some time depending on the size of the finite element model. You can see the output values appear, which prove that the coupling is working. At this stage, it's possible to use all the functionalities of PhimecaSoft with the Ansys Workbench finite element model. For this demonstration, a reliability analysis using a Monte Carlo simulation method based on the surrogate model of the finite element model is performed. Firstly, it is necessary to define the probabilistic model. Right-click on Probabilistic Model, then click on New Probabilistic Model. You have to choose now the associated physical model. In our case, it is coupling. Click OK. The input variables are automatically detected, And for each variables, one of the proposed distributions has to be chosen. There is a lot of different distributions available in PhimecaSoft. For P1, we can choose an exponential. For P2, a Gumbel. For P3, a log normal. For P6, a Rayleigh distribution. And for P7, a gamma. It is possible for each law to change the parameters of the distribution. For example, we can change the standard deviation for the exponential law, and this will change the shape of the distribution. Secondly, it's possible to create a surrogate model by doing a right click on Probabilistic Model 1, then click on Meta Model. Select the output variable. In our case, it's P5, and it refers to the maximal deflection of the beam. Then click Continue. You have to define a new design of experiment. Click Continue. You can choose the type of design of experiment. There is Monte Carlo, quasi-Monte Carlo, or Latin hypercube sampling. In our case, we will choose Latin hypercube sampling design of experiment. We have to decide the size of the design of experiment. In our case, 100 points. Then click on Continue. The next step is to select the type of surrogate model and the type of validation. For this case study, a polynomial KO expansion and a leave one out validation method are selected. All the design points of the design of experiment are then solved. And when all the calculations are solved, the surrogate model is automatically created and the sensitivity or reliability analysis can be performed. Before using the surrogate model, it has to be validated. This is possible by checking the values of the correlation coefficient R2 and the leave one out coefficient Q2. The relative error has to be close to 0, and in our case it is close to 0. And the leave one out coefficient has to be close to 1. In our case it is close to 1. So we are allowed to use this surrogate model for further analysis. The polynomial chaos surrogate model is very useful for global sensitivity analysis because it gives, without additional calculation, the Sobol indices. You can click on Sobol to access the indices chart, the indices values, and the statistical moments of the output. With help of this sensitivity analysis, it's possible to rank the influence of the variability of each input variable on the variability of the quantity of interest. This type of information can help to limit the spread of the quantity of interest in the most efficient way by changing the most sensible input variable distribution. The surrogate model allows us to calculate quickly a failure probability associated to a failure event. First, the limit state is created. Right-click on Reliability Analysis, then click on New Limit State. You have to choose the probabilistic model that is linked to the limit state. In our case, it's Meta Model 1. Click OK. Then the failure event has now to be defined. Select P5. That refers to the maximal deflection of the beam greater than 80 millimeters. Then you have to choose the reliability method you want to use. Right-click on Limit State 1. Then click on Simulation Analysis because Monte Carlo method is a simulation method. Click on Continue. Then you have to choose the algorithm that you want to use. In our case, it is Monte Carlo. And don't forget to give the maximal number of simulations you allow to perform. In our case, 10,000. Click Done, and the simulation begins. When all the simulations are finished, you can access the failure probability and other quantities associated. Before finishing with this video, you have to know that several advanced methods for reliability and sensitivity analysis are available in PhimecaSoft. So feel free to contact us to have further information about our methods and PhimecaSoft.